In this problem, we have a limit, and the question is to use L'Hopital's rule to evaluate the limit. So they're asking us to use L'Hopital's rule. Let's first verify that we can even use L'Hopital's. So when x approaches infinity, the numerator e to the x is also approaching infinity. Likewise, when x approaches infinity, the denominator x to the fifth is also getting really big, so it's also approaching infinity. So we end up with what's called an indeterminate form, and this one is infinity over infinity. So whenever you have a form that's infinity over infinity or 0 over 0, you can use L'Hopital's rule. L'Hopital's rule basically says you just take the derivative of the numerator and the derivative of the denominator. So we have that, so let's do it. So limit as x approaches infinity, the derivative of e to the x is e to the x. And then here we're going to use the power rule to bring down the 5 and subtract 1, so you get 5x to the fourth. Okay, so it's still infinity over infinity, so we do it again. So we have the limit as x approaches infinity, derivative e to the x is e to the x. Bring down the 4, so we get 20x cubed. And it's still infinity over infinity, so we use L'Hopital's again. Limit as x approaches infinity, e to the x. That's still infinity over infinity, so again we're using L'Hopital's, so 60x squared. It's still infinity over infinity, so again, limit as x approaches infinity, derivative of e to the x is e to the x, derivative of the bottom is 120x, and would you look at that, it's still infinity over infinity, so we do it again. So this is the limit as x approaches infinity, the derivative of e to the x is e to the x, and then on the bottom here, here's where the magic ends. The derivative of 120x is 120. Now we can't use L'Hopital's anymore because the bottom is just 120. It's not infinity. So what happens here? Well, as x approaches infinity, the top is approaching infinity. The bottom is constant, so this is equal to infinity. By the way, you can look at this from the beginning and just say it's equal to infinity because exponentials grow faster than polynomials. So in the long run, the numerator is growing faster, so this limit will be, this fraction will tend to infinity. The only reason we use L'Hopital's is because the directions specifically asked us to use L'Hopital's. I hope this video has been helpful to someone out there in the world. Good luck.